Hi everyone. In this video we're going to be looking at the topics covered in Chapter 1 of our textbook. Um, Chapter 1 is dedicated to an introduction to computers, programs, and the Java programming language. A lot of this is just going to be basic review for you, but this is an introductory class and terminology is an essential part to any introductory class. So let's start with what a computer is. Computers, as defined in our book, are electronic devices used for storing and processing data. So in order for us to be able to use computers, we need two things: hardware and software. The hardware is the physical elements of the computer, and the software is the programs that we write to control that hardware, with the operating system being the most important piece of software. So, what kind of hardware do we have in a personal computer? Usually, this is going to be a combination of one or more storage devices, random access memory, the processor, which is the central processing unit, uh, probably one or more communication devices, such as a modem or a network interface card. Input devices, we definitely need a keyboard and a mouse. And output devices, we do need a monitor, and a printer is also another example of an output device. Programs, computer programs or software contain the instructions that tell the computer what to do. And it is important to note that without software, really, the computer is useless. It's just an empty machine. Um, Programs may be written in a programming language such as Visual Basic, C++, C Sharp, Java, Python, PHP, JavaScript. These are all good examples of high-level programming languages. Now, computers don't understand high-level programming languages. In order for the programs to be executed, they must be converted to a language that the computer understands, and that would be machine language. So depending on what computer you have, the machine language is going to be different, but it will always be based on the binary code. So this here is an example of what an instruction to add two numbers could look like in binary. Okay, a major problem with machine language is the fact that programmers find it very difficult to read and understand the code and write the code, and you can see why. It's all ones and zeros. Okay, it is possible to do it, but it is extremely inefficient to program in machine language. Um, Assembly language comes to the rescue. It's based on mnemonics, which means instructions such as this one here. Um, um, every instruction is going to have its own little name, and um, the code is still a bit hard to read. It's still very low level, but the assembly language is a lot easier to understand, read, and write in, easier than machine language. Okay, uh, that's where high level languages come in. Okay, they help us write our programs in a language that is a lot more English-like. So the instructions make a lot more sense to a regular human being. And here's an example of what an instruction in a high-level language could look like. We got an assignment statement here that calculates the area of a circle, multiplies the value of pi uh, by the squared value of the radius. It's still not the English language, but it's close to it. So when you look at it, you can read this: area equals radius times whatever the value of pi is. The way we write programs is we create source code, or source programs, and we need if you're working in an interpreted language, you're going to need an interpreter to take that source code and convert it into machine language code for the computer to execute. Um, or if you're working with a compiled language, then you're going to need a compiler that takes that source code and compiles it down to machine code for the computer to understand. Here's an example of how this works. Interpreted languages take the instructions one by one and interpret them in real time. Compiled languages take the source code file and compile the entire thing into machine code before you try to execute the file on the computer. So once you compile the program on a compiler, you end up with an executable that you can actually run on a computer. So how about Java? Is it interpreted? Is it compiled? Generally, it's considered to be a compiled language because you need to have a compiler. You write your code, your source code in an editor, and then you compile that code in a compiler, and you end up with a program that you can execute. However, you can also argue that it's an interpreted language because the Java executable that the compiler produces is actually a class file that requires one additional step, and it's running it through the Java virtual machine, which in itself is an interpreter. It's designed to take the class files and interpret them for the machine. This additional intermediate layer allows you to make Java system independent, meaning that when you're writing your source code, when you're creating a program, you're not really worrying about the operating system you're going to be running on. Okay, this Java virtual machine layer allows you to isolate yourself from the actual operating system. So once you have written your program once, you can run it anywhere. On computers that have Java virtual machines installed on them. So I guess the answer to this question then would be yes and no. It's Java is an interpreted as well as a compiled language, and you go through both steps. You write the source code, you compile it, and then you take your the class file that's being produced by the compiler, and you interpret that in the Java virtual machine when you need the program to be executed. And this is just a visualization of what I just said. The Java virtual machine is a you can think of it as a device that does the interpretation for you. So once you have created and compiled your code, you can actually run that on any operating system that comes with that can have Java installed on it, because Java is going to include the Java virtual machine. And as I mentioned, the operating systems, we need to point out that these are the most important pieces of software that computers run. They allow you to manage all the hardware. Without an operating system, you're going to have to actually write all the code for managing all the hardware each and every time you create a new program. So how do you work with the CD, or how do you work with the hard drive or with the printer? If there was no operating system, then you would have to include all of that as part of your program as well. The operating system, however, is designed to help you with that, and it takes care of all the low-level details of managing a printer or a CD drive or a hard drive, and you really don't have to reinvent the wheel every single time you write a new program. So why do people use Java? Java is considered to be the programming language of the internet. It's a very versatile programming language. It can be used to create web applications. It can be used to create desktop applications, which is precisely what we'll be doing in this class. It can be used to create mobile applications. Okay, so if you are writing a program for a mobile device, an Android device I should say, because Apple actually uses Objective-C for its apps, or if you're writing a piece of software that needs to run on a server somewhere, on the internet, you're going to be using a slightly different approach. In this class, we'll learn the basics of creating desktop applications, and we'll be using IDEs similar to Eclipse or NetBeans. I did mention Java programs are considered to be portable, which means once you create them, you end up with a Java class file that you can run on other machines. And actually, if you are sharing your Java application with somebody else, you'll probably be sharing a jar file, which is an archive of your entire project. So in addition to your source code files, you'll be bundling libraries and basically everything that your project needs to run as part of one large archive. And when I say large, it's actually normally it's not really large. Here's an example for you. I've got a Xiaomi app here that allows me to get into the operating system of my mobile phone, and it's a jar file. Somebody wrote this in Java, and the size of it is 21.6 megabytes. So this entire project, when I run it, it runs. It's not an exe file, but it runs because the Java virtual machine on my computer is capable of reading this and handling it properly. Right now nothing's happening because I don't really have the phone connected to the computer, but you can see that I can run it. That's what a Java executable usually is. This is what you share with other people once you're done with your project. Okay, the Java Development Toolkit. I do have another video showing you how to download it and install it. So if you are writing web applications, you're using a different kind of Java toolkit. If you're writing applications for mobile devices, yet another type of a Java toolkit. The one that we installed in the other video is called the Java Standard Edition. This is what people use to develop client-side standalone applications. IDE, as I mentioned in the other video, is optional. You can use Notepad or any other text editor to create your source code files, but you're well advised to choose and use an IDE when you're programming in Java because they allow you to be more efficient, and they give you some additional features. So you'll be able to edit, compile, build, debug, and even get online help with your coding. The three most popular IDEs at the moment, NetBeans and Eclipse, are free. IntelliJ IDEA, I believe, costs money. And here's a quick screenshot of what the IDE could look like. This is NetBeans 8.0.2. You're going to notice that you can customize these and you can make them look alike. So the JGrasp IDE that I'll be using looks quite a bit like this. Okay, and we come to our first Java program. It's a simple, short application that displays "Welcome to Java" on the computer console. And let's take a look at the code first, and then we're going to try this out in our Java IDE. So the entire program is actually one big class definition. That's the way that it works in Java. Everything is going to be a class, and we'll talk about object-oriented programming more further in the course. But for now, please assume that your entire program needs to be enclosed in between a pair of curly braces which define the body of a class. Now what you name that class is up to you. Here it's called welcome. And inside that class, at the very minimum, you need to have a main function spelled just like you see it. Java is case sensitive, so please make sure that you keep that in mind when you're programming. You need to make sure that you not only spell things correctly, but that you use the right case. So if you don't have a main function spelled with a lowercase m, your program is not going to run, and the compiler will tell you it doesn't know how to handle it. Public static void main is just a standard definition of defining this function. We'll be coming back to these keywords and explaining them, but this simply says this is my main function. Here is what I want you to start. The thing that you see in between the parentheses is an array of arguments. In this case, we're not going to be running our program with any arguments at all, but in some cases, when you start your program, you may need to pass along some values to it. And this is what allows you to capture those values and use them in your program. On the next line, you see a comment. Comments are just for you, for the programmer, so you know what is going on in the program. But they are ignored by the compilers, so they're not part of the code per se. They're not going to be compiled in any special way. They'll be discarded by the compiler. So this one comment here tells me my program is going to display a message on the console. Which instruction does that? It's this one down here. We only have really one single instruction in our entire program. System.out.println, welcome to Java. Note that this string needs to be enclosed in quotation marks, and the entire argument is in between parentheses. This is a function call that takes one argument. Please also note that there's a semicolon at the end of this statement. So all the instructions in Java, or all the statements, do need to end with semicolons. Okay, now the next few slides visually walk you through the process of creating your program, compiling it, and running it using the console. This is precisely what I did in my other video on downloading, installing, and using the JDK, which is why I'm going to be spending very little time with this and just I'll just explain what's going on here, but I won't do this in the console again. In fact, I'm going to use my IDE to run the same program in just a moment. But on this slide, you see the instructions for opening up Notepad, typing up the code. You then, if you're using the console again, you're going to be compiling your source code program with the Java-C compiler. If there are no errors, you'll end up with a .class file, and you'll be able to run it with the Java executable. And again, visually, here's what could be the output of when we do this. We have created the Java source code file, we compile it, we then run it, and we end up with the result down at the bottom here where we see the display welcome to Java. Anatomy of a Java program. Let's take a closer look at the individual parts of it. So the class name here, when you come up with a name for your classes, you need to make sure you use meaningful names that start with a letter and continue with any combination of letters, numbers, or the underscore character, which is this one. And that you don't use any keywords such as public or class, for example. Keywords are reserved words. They have special meaning and they cannot be used for names of variables. Okay, we'll spend some time with variable naming in our next video, but for now, this is our class name here. It's a good class name. Just remember that your file needs to have the same name as your class. So when you're saving this, you're going to be naming it welcome.java. Okay, the main method, we talked about that. You need to have exactly one of these in your class, in each of your classes that contain executable code. The actual instruction printing welcome to Java on the screen is the system out println instruction. It also adds a new line at the end. We're going to be taking a more detailed look at each and every one of these pieces. Now we're only identifying them. The statement terminator is your semicolon at the very end. It tells Java that you have completed a statement. And I mentioned reserved words. They're used for specific purposes. I believe our textbook has a list of all the reserved words, and you can find those online as well. Blocks of code. Oftentimes, you're going to need to enclose a chunk of code as a block. For example, when you're defining a class, when you're defining a function, or when you have multiple statements that you need to act as a block. We do that through the use of curly braces. Okay, so in here you can see this is the opening curly brace. It basically tells Java where the block begins, and a closing curly brace, which tells Java where the block ends. So each closing curly brace matches the closest to it open curly brace. Okay, so this one curly brace closes the one that you see up here, and nearly all the IDEs, including JGrasp, is going to help you with that. So if you're struggling identifying which one brace goes with which other one, you simply hover the mouse on top of one of them, and the IDE is going to highlight both of them for you. Alright, so that's the curly braces. Parentheses are used with methods. This is when you're defining a method or when you're calling it. The angle brackets are used with arrays. We're going to spend quite a bit of time with arrays as well. The two slashes indicate a comment on a single line. So if you use those, basically you take out everything that follows them from your code. It becomes a comment. It's an interesting way of that you can use it. It's a trick that programmers use whenever they need to take out something temporarily and then put it back into their code. The quotation marks are used for generally enclosing a string or a sequence of characters, and then the semicolon marks the end of a statement. Alright, a couple of words about programming style and documentation. Using comments is not mandatory for your program to work. They're really just for you and any other person that may need to read your code in the future. So people use comments to describe what is going on in their code. The single line comments is whenever you need to add just a short comment to part of your program. If you need to add a paragraph of comments, you're going to use the block comments, which is slash star, and then close it with a star slash. And then finally, if we're not really going to need this in our class, but if you're going to be creating a documentation file to go with your Java program, you can use the so-called Java doc comments. And you can see the syntax here. When you compile your program, Java will be able to extract these and create a documentation file to go with your program. Naming conventions. Please make sure that you use meaningful and descriptive names for your variables, your methods, and your classes. Okay, they could be single words. If they could be multiple words, we're not allowed to use the space. So if you need to create a variable like this, first name, what programmers often do, this is not mandatory either, but it's a good habit to get into. They're going to use the so-called camel case. So you start with a lowercase letter, and then you continue the next word with an uppercase letter. First name, as in this example here, or is prime, or get distance, as you see down here. Okay. Class names, you capitalize the first letter of each word in the name. Okay, as in welcome dialog or compute expression. Once again, this is not obligatory. It's really just a good programming practice. So adopting this type of naming convention is going to help you and other people that may need to read your code. Proper indentation and spacing is also something that is advised in order for you to be able to more easily read your code. Indentation refers to where you place your code on the screen. So when you go from one line to the next, if you are creating code for a given block, you may wish to indent that and then use the same indentation for all the instructions in that block. I'll be reminding you of this as we start programming. Spacing is going to be ignored by the compiler. Again, it's just for you. Here's an example. This would be an example of poorly written code, not because it's not going to work, but because it's a bit difficult to read, as opposed to this one. It's more legible than the one on top because of all the spaces that are here. Block styles, both of these are considered to be good programming practices. Either use end of line styling or next line styling. You can see how the curly braces are used to set aside a block of code. Just please try and be consistent. If you like this one better, just stick to it. If you like this one better, then use it, but stick with it throughout your entire project. Programming errors, they could be syntactical errors. This is where you, for example, misspell something. They're detected by the compiler. These are the errors that are most easily fixed by the programmers. Runtime errors are the ones that the compiler doesn't catch, but that cause your program to crash, to abort execution. We'll see an example of a couple of these. And then logic errors are the ones that are hardest to catch because the compiler doesn't identify them. The code still makes sense to it. They don't cause the program to crash, but they contain some kind of logic error that causes an incorrect result to be produced. A quick example, this would be an example of a syntax error because in my welcome to Java statement I'm missing the closing quotation mark. So the compiler is going to catch this and it will give me an error message, a pretty good one too, saying okay, you forgot to close the quotation marks, and I can fix that easily. Examples of runtime errors include reading in the wrong data type or dividing by 0, for example. Both of these could cause your program to crash. And then logic errors. Here's an example of a logic error. Everything in this program is correct. It will execute in terms of syntax. Everything is correct. However, this is going to produce the wrong result because in Java, as in most other high-level languages, when you're dividing two integers, you'll end up with integer as the result. And in fact, this 9 divided by 5, the formula is correct mathematically speaking, but if you run this in Java, when you divide 9 by 5, you'll end up with 1 as the result. Okay, and that's why you'll end up with the wrong result. This is considered to be a logic problem. Okay, and that was a quick introduction to Java. I did promise you I would run the code inside the editor. Let me grab this last piece of code here. I'm going to fire up JGrasp real quick, and this is a good point for me to point out that you don't really need to create a project for all of your coding. You can just create a single Java file and run that. You don't have to have a project in order to be able to execute your Java file. All right, I've got a class file. It's called show logic errors. So when I save this, oh, look at this. Okay, JGrasp already has the correct name for my file. I just need to go into my projects. It's in they're inside documents. Save that. I got my main function here. I got everything I need, so I can just go to build, compile, compilation succeeded, run, and there's the result, which is the wrong result. So how do I fix it? The easiest and quickest way would be to change one of these values to a floating point value, which means one that has a decimal point and a fractional part. So now Java knows that this division here is not going to be just an integer division, it's going to be a regular mathematical division. So rebuild and then run, and there it is. Now I've got the correct result. And this was a really good way to end this video because it's going to transition us to our next video, which includes operators as well as mathematical operators in Java. Thanks very much for watching. Goodbye.